Hello, today we are going to discuss blood types. Okay, so there are two different genes involved in blood type. There's one gene located on chromosome 9 that produces a protein on the surface of red blood cells. The protein is named either A or B. If the blood cell has both A and B proteins on its surface, its type is AB. And if the blood cell has neither A or B proteins on its surface, it is type O. So what blood type is basically saying what kind of proteins are sticking off the surface of the cell membrane of red blood cells. So you can have an A protein, a B protein sticking out. You could have both of them or none of them. And you can see that in the image in the top right, or sorry, top left. Antigen is just a more scientific name for saying a blood protein or a protein. Okay, so that's all antigen means. It's a protein sticking off the cell membrane of red blood cells. The other gene, known as the rhesus factor, is located on chromosome 1. It's called the rhesus factor because it was first discovered in rhesus monkeys. But this is a different kind of protein on the surface of red blood cells. If the blood cell has this rhesus factor protein sticking off the cell membrane, it is then called positive. If it does not have this protein sticking off this rhesus factor, it is known as negative. So, two different genes involved in blood typing. One gene gives you the lettering such as A, B, or O, and the other gene determines if your blood is positive or negative if it has that rhesus factor protein. Okay, now allele representations for genotypes. So we talked in a previous video about how the base letter, you can use a base letter for the genotype with a superscript letter, and that's a bit more accurate. And the reason it's more accurate is because in this circumstance with blood typing, A blood and B blood have a co-dominant relationship. So one is not really positive, or sorry, dominant or recessive to the other. They are have like equal level of dominance. So that's why it's better to use the base letter with the superscript for this instance. So the capital I, you always use I's for blood as the base letter, then the superscript A for the A allele, I superscript B for the B allele, and then if it is O blood or O allele, so it doesn't have the A antigen or B antigen sticking off the red blood cell, it is now a lowercase I, so kind of combining the newer genotype notation that we learned with the first genotype notation that we learned with the capital and lowercase letters together. So you can see in the top left how IA and IB alleles, that is a codominant relationship, but each of them are individually completely dominant to lowercase I or O blood. So if there's an IB and an I lowercase I allele paired together, that is going to result in B-type blood. Same thing if IA or A blood, or sorry, IA and a lowercase I are paired together, that results in A blood. The rhesus factor is much more simple. It's a capital RH if that's representing having that positive antigen protein sticking off the red blood cell. And then we use a lowercase rh for a negative or not having that protein sticking off the surface of red blood cells. There are different ways I've seen people use to represent the rhesus factor. I learned it where you use both an R and an H, as you can see in this slide, so I'm just going to be teaching it that same way. Okay, so here you can kind of see how these would go together. So you can see on the left, IA, that would be a genotype for A blood, but also IA lowercase I, that also would be a phenotype for A blood, or genotype for A blood, because IA is dominant completely Same principle for B blood, so IB is B blood. IB lowercase I is also B blood. Since IA and IB are codominant with one another, that's how you get AB blood. And then if you have no A's or B's, that would be just two lowercase i's, and that would be O blood. For the rhesus factor, two capitalized RHs makes positive, one capital RH and a lowercase RH. That still makes it positive because the RH is completely normally dominant to the lowercase RH, and then two lowercase RHs make it. So for a full genotype of a person's blood, you combine the genotype of basically the lettering of the blood with the genotype for the positive or negative. So you'll put those two different genes again, you put those together to make one genotype. So for example, if someone was AB negative, their full genotype would be IA, IB, lowercase RH, lowercase RH. That's just one thing to it. Okay, antibodies and antigens. Okay, so I've said how antigens, they're the blood protein that's sticking off the surface of the red blood cell. Antibodies are also a blood protein, but they are produced in response to and counteracting a specific antigen. So antibodies combine chemically with substances which the body recognizes as alien, such as bacteria, viruses, and foreign substances in blood. So what happens is, say, for example, you've got A blood, and those antigens are floating on the surface of those red blood cells, and then B blood comes into your system somehow. You're going to make anti-B antibodies that will attach to the B antigens sticking off the surface of those B blood cells. And then what's going to happen is, if you can see in the picture, the top left picture, basically antibodies clump all this bad blood, foreign blood, bacteria, viruses, whatever it is, and then when it's all clumped together, white blood cells can then come in and basically take care of the rest of it. So antibodies clump everything together nice and neat for the white blood cells, T cells, whatever you want to call them, to basically finish the job. So reading now the bullets, so an organism produces antibodies to attach to antigens. An organism does not produce antibodies to attach to its own blood. So for example, if you've got A blood, you're not going to make A antibodies, because if you did, you'd be attacking your own blood and basically, killing yourself that way. That'd be a very bad problem if your antibodies that were attacking your own blood. Then, last bullet is an organism only produces antibodies to attach to foreign antigens. So again, if I have A blood, no part of me is ever going to be making an A antigen. But instead, what I would be making is an anti-B antigen. And let's say I was A negative. So if a positive blood type came into my system somehow, I would also make positive or RH antibodies to attach to the RH antigens of foreign blood. Okay. Blood donation. So if an individual receives blood containing foreign antigens, they will experience an ABO incompatibility reaction. Symptoms of that include a strong feeling that something bad is about to happen, fever and chills, breathing difficulties, muscle aches, nausea, chest, abdominal, or back pain, blood and urine, and jaundice. Okay. So if you are in the medical field where you are needing to supply someone with blood, really important to make sure you do not cause an ABO incompatibility reaction. So O negative blood is considered the universal donor because it has no antigens on its surface for any antibody to attach to. So O negative can be given to anyone because it is impossible for antibodies to attack it because there's nothing for them to attach to at all. AB positive blood is considered the universal receiver because it has all of the antigens from blood on itself. Antibodies are not made for the organism's own antigens, so any blood type can be received. So the only antigens that exist are A, B, and the Rh factor. So if you already have all those on your blood cells, so if you're an AB positive person, you have all those antigens already, your body would not even make any antibodies at all for those antigens because you already have them all. And then, of course, you can't be attacking your own blood, so that's why that would be the case. And then the last bullet point is that an organism cannot receive blood with more dominant or foreign antigens. So if we look at the picture in the top left, you can see like AB positive is dominant to AB negative. So an AB positive person can receive AB negative or AB positive blood. A positive can receive A negative, O positive, O negative. B positive person can receive B negative, O positive, or O negative. So basically, if you are positive blood, you can receive anything positive. If you are A, you can receive another A or O. B, you can receive another B or O. So basically, it's two different things factoring into this. It's the blood type lettering and then the Reese's spread. In the GIF below, I really like this GIF because it shows exactly what blood types can be donated and received by who without receiving an ABO incompatibility reaction. It's already played through a couple times, so I'll let you just go back and watch that loop on your own. But I think it's really useful if you use that in turn with the picture above the top left. I think you'll really get a good understanding of this. Thank you for watching. Please share and subscribe, and remember to spread kindness.